Find two natural numbers a and b such that a plus 2ab plus b is equal to 22. Ladies and gentlemen, welcome to this tutorial session. Here we are given this Olympiad question to find the two natural numbers a and b such that a plus 2ab plus b is equal to 22. Let's start. A plus 2ab plus b is equal to 22, where a, b are natural numbers. We are asked to find the values of a and b. If we look at it, the only way forward is actually to be able to factorize the left-hand side of this expression. To factorize the left-hand side to have two linear factors multiplied together to give a number on the right-hand side, so that later on, when we decompose that number on the right-hand side, we are going to form two equations that will enable us solve the values of the two unknowns a and b. So our challenge here is, how do we now factorize the left-hand side? So let's look at it together. If we try to factorize in this form, the way it is, we can see that if we take the first two terms, we have a common. If we take the next two terms, we have b common. But there's actually no way forward, because if we take out a here, we're going to have a into 1 plus 2b. And then we'll be left here with plus b. And there's not much that we're going to achieve to be able to factorize the left-hand side. If we try to consider the next two terms, we find b is common. So if we put b out, we're going to have 2a plus 1. And then there will be a here. If we look at it, there's actually no way forward for us to be able to factorize this expression further. All right, so what then do we have to do? All we have to do is to multiply all through by 2. Let's go ahead and do that, and we'll see. So multiply both sides by 2. Multiply both sides by 2, we have 2 into a plus 2ab plus b is equal to 2 into 22. Let's open the parentheses. That gives us 2a plus 4ab plus 2b is equal to 44. Now from here, we will look at the first two terms. We will take the first two terms. We will see that 2a is common. 2a into 1 plus 2b plus 2b is equal to 44. We are seeing 1 plus 2b here, and this is already 2b here. So all we need to do is to add 1 to both sides, so that we have 1 plus 2b, 1 plus 2b, in order to continue our factorization process. So all we need to do now is add 1 to both sides. Now when we do that, we're going to have 2a into 1 plus 2b plus 1 plus 2b is equal to 1 plus 44. That gives us, okay, so we see here 1 plus 2b is common. It is here and it is here. So we can factorize out 1 plus 2b into, when we remove 1 plus 2b, we're left here with 2a. 1 plus 2b, remember, the coefficient here is 1. It's like 1 multiplied to 1 plus 2b. So when we remove 1 plus 2b, we're left with 1. So we have plus 1 is equal to 1 plus 44 is 45. Okay, so we have succeeded to factorize the left-hand side to have two linear factors in terms of the unknowns a and b. So we have this factor multiplied to this factor giving us 45. Remember, we have to solve for a and b. So what do we now do? We have to decompose the number 45 into its component factors. Let's do that. So we know that 45 can be decomposed as 1 multiplied to 45 or 45 multiplied to 1. Also, 45 can be decomposed as 3 multiplied to 15 or 15 multiplied to 3. Again, 45 can be decomposed as 9 multiplied to 5 or 5 multiplied to 9 and 9 multiplied to or 9 multiplied to 5. Okay, these are the possible decomposition of the number 45 using its factors. Alright, so this will help us form two equations from where we'll be able to solve for the values of A and B. Now, let's call this case 1, call this case 2, call this case 3. Let's go ahead and work and see. Case 1, 45 can be decomposed as 1 multiplied to 45 or 45 multiplied to 1. So we are therefore saying that 1 plus 2b into 1 plus 2a can either be written as 1 multiplied to 45. So from here, this can be split into two equations. This factor go with this factor and this factor go with that factor. So here we'll either have 1 plus 2b equals 1 or and 1 plus 2a equals 45. Okay? This product giving us this product means either this is this and this is that. Later on, as we're going to see, this will be that and this will be this. So this is the first situation that we have here. We are with this. Let me take it. All right, we have taken that first situation. So now here it will therefore mean that if we take this one from the left hand side to the right hand side, it will mean 2b is equal to 0. From here we can conclude that from here when we divide both sides by 2, we'll conclude that b is 0. So b is 0 there. Now if we take the second equation, we take this one from the left hand side to the right hand side, we are left with 2a is equal to 45 minus 1, 44. So if we divide both sides by 2, it will now mean that, you see 2 cancels, 2 here, 1, 2 there, 22. It will now mean that a is 22. This is what we get when we take the first situation. B is 0, A is equal to 22. Now, let us take the second situation in case 1. The second situation in case 1, we are still working with that statement, but this time around it will be 45 multiplied to 1. So we have 1 plus 2b into 1 plus 2a is equal to, this time around, 45 times 1. This therefore means that we can form the equations 1 plus 2b equals 45, 1 plus 2a equals 1. If we solve this one very well, we're going to have, we take 1 from the left hand side to the right hand side. Alright, we're going to have 2b is equal to 44. If we divide both sides by 2, we obtain b is equal to 22. Here, if we take 1 from the left hand side to the right hand side, we're going to obtain 2a is equal to 0. Or divide both sides by 2, we'll have a is equal to 0. So, if we look at it carefully, we see just a swap in the solution of the first situation of case 1. In the first situation of case 1, b was 0 and a is 22. In the second situation of case 1, the results just swap. Okay, the value of b that was in the first situation became the value of a, and the value of a in the first situation became the value of b. So with that in mind, let us see if we obtain the same thing in case 2. Case 2, 45 decomposed to 3 times 15 or 15 times 3. So again, it's the same product. 1 plus 2b into 1 plus 2a is equal to, let's take the first situation in case 2, 3 times 15. Now this can help us form two equations. If this product gives us this product, then we can say this is equal to 3. 1 plus 2b is equal to 3. and 1 plus 2a is equal to 15. Is equal to 15. If we solve this, we take 1 from the left hand side to the right hand side, we have 2b is equal to 4. We divide both sides by 2, we have b is equal to 2. We have b is equal to 2. If we come here, we take we take 1 this way, it becomes 3 minus 1 is 2. So b is 1. Sorry for that error. If we take this is positive 1, taking it this way will become negative 1. So 3 minus 1 should be 2 and not 3 plus 1. Alright, here we take 1 from the left hand side to the right hand side. It is subtraction. 15 minus 1 is 14. So we have 2a is equal to 14. If we divide both sides by 2, we have a to be 7. A to be 7. So this is the first situation of case 2. A is 7, B is 1. Let's see the second situation of case 2. Let us see the second situation of case 2. The second situation will now be this. Alright, so we are saying 1 plus 2b into 1 plus 2a is equal to 15 times 3. This product equals this product. So we can safely say this is equal to 15, this is equal to 3. So we have 1 plus 2b is 15, 1 plus 2a is 3. If we follow up this, we take the 1 from the left hand side to the right hand side, is subtraction. 15 minus 1 is 14. So we have 2b is equal to 14. If we divide both sides by 2, we see that b is 7. B is 7. Let's solve for a here. Take the 1 from the left hand side to the right hand side, it will be 3 minus 1, which is 2. We divide both sides by 2, we see that a is 1. So we're through with case 2, having all the solutions of case 2. Let's take the last case. Case 3. 45 decomposed as 5 times 9 or 9 times 5. Again, is the product 1 plus 2b, 1 plus 2a is equal to, let's take the first situation, 5 times 9. This product giving us this product, we can safely take this first one as 5 and take the second one as 9. Solving this, we take 1 from the left hand side to the right hand side. Remember, this is positive 1. Going this will become minus 1. So it's 5 minus 1, which is 4. So we have 2b is equal to 4. So we divide both sides by 2. We see that b is 2. B is 2. Now let's solve this other one. Take 1 from the left hand side to the right hand side. This is positive 1. Going this will become minus 1. So it's 9 minus 1, which is 8. So we have 2a is equal to 8. If we divide both sides by 2, we see that a is 4. Okay, this is the first situation of case 3. Now what about the second situation? Alright, where 45 is decomposed as 9 times 5. Alright, so we also have again the same product. So we're saying or 1 plus 2b into 1 plus 2a is equal to 9 times 5. This product giving us this product, we can safely conclude that 1 plus 2b is 9. 1 plus 2a is 5. Solving this, take 1 from the left hand side to the right hand side. This is positive 1, going this way is subtraction. 9 minus 1 is 8. 2b is equal to 8. If we divide both sides by 2, we see that b is 4. Again, we are seeing a swap coming up there, swap of values. Taking 1 from the left hand side to the right hand side, this is positive 1. Going to the right hand side becomes subtraction. 5 minus 1 is 4. We have 2a is equal to 4. We divide both sides by 2. we have A is equal to 2. Alright, we have handled all our 3 cases and we've seen the set of possible values for the numbers A and B, the natural numbers A and B. So let us write now a set of all possible solutions. The set of all possible solutions will be, so we'll now say set of solutions will be, in the first case we had 22, 0, 22, 0, or 0, 22. The second case we have 1, 7, or 7, 1. 1, 7, or let's write it in the order A, B, yes. Anyway, 1, 7, or 7, 1. And then in the last case, case 3, we have 2, 4, or 4, 2. 2, 4, or 4, 2. Okay, so this gives us the set of all possible natural numbers A and B that satisfy the condition that A plus 2AB plus B is equal to 22. Now we can always test to be sure that what we have is true. Let's take any 2 pair of solutions here. Let's take, for example, 22, 0. Remember, it's the same thing as this. And for example, 4, 2. Let's test and see if we get a confirmation. So we're taking AB to be 22, 0. That means A is 22, B is 0. Let's put on the left hand side to see if our left hand side result will give us 22. Alright, so we'll say put in A plus 2AB plus B. Let us see if this result will be 22. Alright, A is 22, so we'll put 22 plus 2 into A is 22 multiplied to B. B is 0 and then plus 0. So we'll have 22 plus 0 multiplied to 22 is 0, multiplied to 2 is 0, plus 0, that gives us 22. So we have shown that the left hand side, this is the left hand side, gives the right hand side. The left hand side gives the right hand side. So the solution 22, 0 or 0, 22 is correct. Now what about this other one? 4, 2 or 2, 4. 4, 2 or 2, 4. So here we're saying AB is 4, 2. That means A is 4, B is 2. Let's put it on the left hand side expression and see if we'll get the result of the right hand side. So we'll put in A plus 2AB plus B. Alright, our A is 4. So 2 into 4, our B is 2. Then plus B again 2. Let us see if this will give us 22. If it gives us 22, then we'll conclude that the values 4, 2 or 2, 4 are correct. Now let's go. We have 4 plus 2 multiplied to 4 is 8, multiplied to 2 is 16. So 4 plus 16 is 20 plus 2, that gives us 22. Okay. So we have shown. We can still go ahead and even test 1, 7. There's no problem. 1, 7 or 7, 1. So we'll put it there. A plus 2, AB plus B. A is 1, B is 7. So we'll have 1 plus 2 into 1 multiplied to 7 plus 7. We have 1 plus 2 multiplied to 7, 14 plus 7. So we have 1 plus 14 is 15. 15 plus 7, 22. So our solution set there has been verified.